Hey guys, this video will be looking at exercise 2I and the next video will be looking at exercise 2J. I'm hoping at this point that you would have received three different forms of resources or notes. 2I, exercise 2I, notes to go into your book. Exercise 2J as well, which we'll use for the next set of notes, and then also a template that will help you with 2J. I've also put some solutions up for 2J, some teacher notes, just for some extra information. So this exercise 2I, comparing the distribution of a numerical variable across two or more groups. 2I and 2J will help you with the next SAC for this data topic. With this in mind, a lot of this is investigating and comparing and making judgments based on what data has been presented to you. With the previous SAC, the layout is here's some data and tell me what you can find from this. Where's the mean? What's the median? What's the IQR? But with this set of work for 2I and 2J, you're going to be looking at drawing some conclusions, okay? So there's quite a bit of investigating that is involved. It is very topic heavy, okay? So it does make sense to compare distributions of data sets when they're concerned with the same numerical variables, say height measured for different groups of people, for example, a basketball team or a gymnastic team. Maybe you want to compare the two and see if we can make some judgment calls if one set group, say basketball team, could maybe be generally taller than the gymnastic team. We can make that assumption, but we need data to back it up. So for example, it will be useful to compare the distributions for each of the following. These are just different examples. The maximum daily temperatures in Melbourne in March and the maximum daily temperatures in Sydney in March. Obviously, them two could be different, but we need data to make that conclusion. Or maybe we can look at the test scores for a group of students who had not had a revision class and test scores for a group of students who had a revision class. Again, it's safe to make an assumption that there will be some type of shift or change or variability between the two groups, revision and not revision. We need data to back this up. So each of these examples, we can identify two variables. One is always going to be numerical, regardless of whether it's discrete or continuous, and the other one is always going to be categorical, regardless of whether it's ordinal or nominal. So in that previous example, the variable maximum daily temperature. The variable maximum daily temperature is numerical, while the variable city, which takes the values Melbourne or Sydney, is categorical. And the other one, the variable test score, is numerical, while the variable attended a revision class, which takes the value either they did or they didn't, is categorical. Okay, so there's always going to be numerical and there's always going to be categorical when you have two groups. Okay. So when we compare these distributions for numerical variable across the two and sometimes more groups, the report should address these very important key features. The center, also known as the median or Q2, the spread, both the range, the highest versus lowest, and the IQR, the Q3 take Q1. I should also talk about the shape, whether it's symmetrical, positive, or negatively skewed, and any possible outliers that you might come across. These are the four main things that you should talk about for both set groups, and then finally drawing a conclusion or comparison between the two. Okay, so look at this example here. Now on the screen, I've got the answers already written down. The one main thing that I should suggest to you is these little notes that you see here. If you wish, you can write them down, and at any point you can pause this video to write these set notes down. Again, this can be found in the Compass resources. You just want to make sure that the next set of notes, which I'll scroll down to in a second, they definitely go down. Okay, they are definitely to be written down in the notes that were provided. Okay, so let's get to it. Let's try to figure out what type of context we're looking at and what type of comparison are we gonna draw. So I'm just scrolling up and down a little bit just to get this all fixed. Okay. So a back-to-back stem plot differs from the stem plots you have met in the past in that it has a single stem with two sets of leaves, one for each of the two groups being compared. So right now we're used to just seeing stem on one side with leaves. This one here is a back-to-back stem and leaf plot, and with this we can group two groups with this. Okay. This is the male life expectancy in years, so how long males tend to live for in years, and we obtained different people from 1970 from different countries, and then we also obtained different people from different countries 40 years later, 2010. Now you can obviously see that there are some comparisons between the two, but in order to read this age right here for 1970, this is a person age 38, not 83. Okay, the stem will be the same for both 2010 and 1970. The leaves in 1970 are just shown first, then the stem, but you will still read this age as 38. So that means when they took someone randomly from the data set, someone in 1970 lived up to 38, which you can consider maybe an outlier. It's a very young age. No ages in the 40s, and then in 1970 there was a 52, a 54, and a 59. On my screen is a bit blurry because of the scanning, so apologies for that. In 2010 there was someone that passed away in, I think that's a 56 or 58. Anyways, how you would go across this with the situation, the expectancy, the actual life expectancy, or how old the males will live up to, is considered the numerical variable, and then the year, despite the fact that these are numbers, remember they are categories. They represent two different categories. So the actual year in which they lived up to is considered the categorical data. So here's the numerical, their age, life expectancy, categorical, the year. So we're going to use this back-to-back stem plot and summary statistics provided to compare the distributions in terms of their center, spread, and also draw an appropriate conclusion. Now, just to be safe, you also should write the range for each one, highest minus lowest. So the range for 1970 is 36, so that's highest age minus the lowest age, and the range for 2010 is 22. Again, the highest age minus the lowest age. Now I'm gonna scroll this down, and what you're gonna do is you're gonna copy this, set out, and these are the things we're going to be talking about. So the center, the median life expectancy of males in 2010, this is provided already within the question. This is 76 years, so this is a median, the middle value. If you compare it to the 1970 median, it's higher. There's essentially 9 years higher. Because in 1970 the middle value was 67. So as you can somewhat tell at this point, as the years went on and on and on, it's safe to make an assumption, not conclude yet, but make an assumption that the life expectancy for males in this case is slowly getting higher and higher. Okay, so that's all you got to talk about for the center. For the spread of the life expectancy of males in 2010, specifically the interquartile range, so the middle range for 2010, 8, and 22. This is smaller than the life expectancy in 1970. The IQR in this case is 12.5 and 36. So it's one thing to see these numbers and just say one's higher, one's lower. What this actually is saying is in 2010, the range, these age ranges being smaller meant that there's not this wide variability of age where someone, a male in 2010 will die or pass away. So you're not going to get a wide range. It's less likely for someone in 2010 to have, assumption-wise anyways, to pass away at a younger age. As you can see here, there's quite a lot of these young ages missing, as opposed to 1970, where you've got this middle value here of 38. There's this big range here, especially in the interquartile range. It's quite bigger in comparison. Okay. The center, spread, and draw an appropriate conclusion. Now, just before you do, it's also good to talk about the shape. Both of these are negatively skewed. So how you would read that is, if you were to read this from left to right, it is negatively skewed. So most of these numbers here tend to negative, and this here as well. And the last thing, you could possibly talk about any possible outliers, which I said before. So again, 38 is definitely considered an outlier. I like to tend to think so anyways, but we don't need to do any maths about it. You can just say that it's possible. But for now, the center and spread, the main things you want to talk about. So to draw a conclusion, the median life expectancy for these countries, I tend to think anyway, has increased over the last 40 years, and the variability, that range that we were talking about from the bigger range and the IQR, so the variability in life expectancy between countries, that's decreased. It's not as spread out anymore. It's actually going to get a bit more narrower because the IQR and the range in 2010 has become less and less. Okay. You can also talk about how it changes. You can also talk about the numbers, about how it changes, the values that the IQR and the range take. But this right here will count as a good conclusion.